Right, so my delay line is working. The blue trace is my delay line. When I move this switch here, watch what happens to my delay line on the blue trace. And watch the RPM. Now, when I turn the knob the other way, back the other way again, and I turn it clockwise, anti-clockwise, look at the current. Right, so basically it seems to work best at the far end of all these chokes. Which means I need more millihenries, basically. Let me just check that. Oops. Right, so when I adjust the triac, which is here, when I adjust this triac with this trimmer, get my screwdriver in it. Now let's look at the blue trace. Look at the RPM going down. Now if I turn it back, RPM goes up. Right, see it going up. I have to tweak it a bit. So I can't do this very easily when I'm holding the phone, but basically when I'm tweaking, oh, my hands are gone. It's this blue I'm checking, I can't keep my hands still. Look at the state of me, I'm in a right wreck. I'm in a right mess at the moment. I shouldn't be working at all. Right, let's just tweak this for maximum RPM. I'm going too far the wrong way. It's about there. I can tell by the pulses on the yellow trace. When I tweak it, and when these little pulses here, the little one here, when that gets bigger, RPM goes up. That's what I was telling you in previous videos. So my battery might not last out because I'm using a single row of cells right now, but I just wanted to demonstrate this, and that's what I'm talking about. My LEDs giving me an indication of what's going on, and these basically flicker on when the triac has been activated. I did do a test earlier, but it didn't. I had a short circuit. I had a solder bridge on one of my components that I'd soldered the coil in, and I had a solder bridge, so I had to basically take the board off again and check it out. So yes, it does work, and I'm only pushing out 81 milliamps right now. That's because these super capacitors are charged up pretty well, and they're driving the LEDs as well. So let's turn the LEDs off. Let's see. Right, I've turned the LEDs off now, so all the power's going into the super capacitors now. So 124 milliamps, so they're pretty well charged right now. So I have to connect my voltage meter back up at the moment. It's been off because I've been doing resistance checks on my board. Oops, I knocked the switch then. So we're at 5,500 RPM now. The blue trace is this scope here, and it's connected to the center winding of the two exit coils, which is the middle. So it's basically reading the center voltage of these two exit coils, which are at the top. And I put it on there because I thought that was the best place really to get a linear reading between the two coils, and that's why I can see that little pulse on the scope when it moves around. So yeah, it's fun and we're making some headway here. Oh, I forgot to put my capacitor back in. Yeah, I've got to put this thing back in here. Hang on. I'll have to retune it all now. My LEDs just went out. Yeah, current's gone up, look, you see. Right, let's just retune this again. And my LEDs aren't as bright right now. Let's try another tapping point. You probably heard it slow down a bit when I moved the tap point. Well, we're still at 5,500 RPM. Current into the supercapacitor is 120 milliamps right now. I need to connect up my meter really because I want to see what the voltage is at. I'm just trying to Where's the red one? Come here. Ah! Flipping thing. I'll put the red one on first, I think. These leads are a pain, they tend to fly off on you. Ah! Stay on, you twat. Sorry. Okay, so we've got quite a big voltage in there right now. 13.2 to 30.30. It's jumping around a bit. It's charging up pretty fast though. Yeah, all interesting stuff. Actually, let's take this capacitor out and see what happens to my current, because it's 116 right now. Let's just take this out. I dropped a little bit. It might want tweaking a bit. Oops, my capacitor just rolled away. I think I'll leave it out for now actually. Seems because it's changed that, putting the extra 2 coils has changed everything. I have to reset my scope. It's jumping around a bit. I'll leave it there, I think. So current, the silver capacitors are virtually charged up. Yeah, it seems to be better on the end one. Look how it slows down when I get it detuned. Look at this. Drops like a stone. Oh, what does current do when I do that? Detuned. Current goes up a bit. But it just starts dropping again as soon as the RPM starts to drop. So basically you think, oh, you're getting more power though. No, I'm not, because what happens then is the drag takes effect. The RPM slows down. As it slows down, the current basically falls back to what it was before. So you end up with less power. You're using more power to drive everything. So you're actually losing power when you detune it. Because what happens, as I say, is it might push out more power initially, but the system slows down and you end up back at the same amount of power as before with less efficiency. So it's important to tune it so you get better RPM, less drag. And you'll gain the extra power by the simple fact that it's running faster anyway. So that's the objective anyway. That's what we're trying to do. I mean, I'm at 5,700 RPM right now, and I'm still drawing 98 milliamps. The silver capacitors are virtually charged up. The maximum voltage of silver capacitors is about 16.3, I think, or 16.5. Alright, it's 6 times 2.7. I think it's 16.3. Anyway, well, anyway, I need to put a load on them now, so I'm going to put a load on. Let's stick the let's put the LEDs on. Actually no, I'm going to send this power to my battery, which I'm charging up over there, my solar battery, because it's pretty flat right now. So let's shunt that power across there. If I can get the damn wire in. This wire is not very good. There, it's going into my solar battery right now. So I'm dumping 600 milliamps into my solar battery at the moment. Oh, my meter's gone over the limit. Oh, oops, hang on. I don't want to blow my fuse. Let's go to 20 amp range and see what's happening. So yeah, I'm drawing 600 milliamps. So minus 500 milliamps right now. I had to go into 10 amp range. It was over my limit on my meter. I don't want to blow my fuse in my 400 milliamp range. So that power at the moment for the generator from the supercapacitors here is now going into my solar battery over there. I'm also charging it with a balance charger as well. So that's the current that's going in from these supercapacitors. The reason I'm doing that now at the moment is because my solar battery is pretty flat. Actually, it's very flat. I mean, it was we've had no sunshine here for weeks. It's been overcast every week, every day I should say, for quite a few weeks now, and I run my solar battery down. So at the moment, so I'm still losing energy at the moment, because when I see a plus on that meter, it means power from here is charging that battery over there, right over there. So at the moment this is drawing the power out of the supercapacitors, which is probably why it says minus 0.07. And the supercapacitors over here are at 11.96 volts. So yeah, we're doing some proper work at the moment. Instead of dumping it into the LEDs, which is a bit of a waste of energy, I'm actually dumping it into some batteries which need charging anyway. So, and my batteries are holding up quite well. I'm still less than 800 milliamps on to the motor. It's drawing less than 800 milliamps because the yellow LED is not lit up, and we're at 13.81 volts, which is pretty standard setting now. My triac is cold. My resistor's probably getting a bit toasty. Actually, it's not too bad at the moment. I'll have to put a bigger resistor in here, this little thing here, because if that ever opens circuit, these LEDs are going to get fried. Well, they'll probably pop their heads off. They'll probably blow their tops, as they say. I've got plenty more LEDs anyway, but yeah, all interesting stuff. So what is it really telling me? What it's telling me is really that I need more millihenries. So what I'll probably have to do is rewind some of these chokes and try and get 2 millihenries per choke, and then I'll have more millihenries to actually switch between, because it seems to work better when I'm at the far end, which is on the last choke, because every choke that's on here has a capacitor associated with it, which is on here. So L1, L2, L3, L4, they all have capacitors of about 4.7 microfarad between there and the other AC cycle, and these are non-polar capacitors, so they're actually working in AC. So the gen coil basically sends the pulses through the coils, which there's a delay between the time that the capacitor charges and when the L coil, that is the inductor, becomes low impedance, and then that power goes through to the next stage and so forth, and then we inject that power to our exit coil, which is through a triac, which is what you saw me adjusting with a trimmer pot. So when I adjust this little trimmer pot here, I'm actually adjusting that triac right there, and I've got a 4.7 nanofarad on the gate just to smooth out any noise, whatever. That also helps to create a delay between when it switches on, which is more delay is better in this situation, because I want to trigger it late in the cycle, so that when my generator coil magnets are actually out of the way of the main coil, the exit coil comes into play. So to explain it, the generator coil is basically there, and the exit coil is right down the side here. You can't really see it because the plastic's in the way, but it's right down there. So there's a time difference between this point here and that point there, and that's why I need the delay, because that other coil has to be energized late, and I need to store the energy from the generator coil in capacitors, which is why I've got the capacitor network. So it's an LC capacitor network. So I need to store that energy and then deliver it at the right time to basically negate some of the drag or reverse torque that we have. And look, interestingly, my meter is now showing about 0, which is good, and my super capacitors are at 11.8 volts. And I'm still charging my batteries over there at 100 milliamps. So the 100 milliamps that I was talking about earlier, the 100 milliamps I was showing you on the meter earlier is now going into my solar battery. Anyway, that's all for now. That was an update, and I'm not pushing out much power right now because, as I say, I've still got work to do with this. I've still got some tweaking to do, but it's doing pretty well. I mean, I'm actually doing a lot faster than I was previously. What we can see is improvements on the RPM really right now. So RPM is doing pretty well considering. Yeah. Anyway, these batteries are about to die. Probably they won't last long. They'll soon start to die off in a bit, and that 13.81 volts will suddenly start to drop. So I might as well end the stream now, because I want to keep an eye on the things and do some more testing before the batteries die on me. Anyway, thanks for watching.